Hi class, welcome back again. Today's lesson is about alternating current through a capacitor. This is class by Raj teaching for Physics Form 6 Semester 2. Learning outcome for today's lesson, we need to define impedance. Impedance of a circuit can be determined by drawing a phasor diagram. So, in order that we will learn how to sketch the phasor diagram for an RC circuit, an RL circuit, and use the formula for impedance in a RCL circuit. Now, what is impedance, class? Impedance is when you have a resistor, inductor and capacitor, you connect it in an alternating circuit. The total opposition to the current, to the alternating current, is known as the impedance of the circuit. Impedance is symbolized by the letter Z and is measured in the unit of ohms. Now, like you see, if you have a perfect resistors, it will possess resistance. And you have inductors and capacitor, their opposition is called reactance. But impedance extend the concept more. You see, impedance is a total opposition in the circuit. If there is a resistor, there is a capacitor, there is an inductor, then impedance means is a total opposition of the resistance and the reactance in the circuit. And when you express an impedance, you need to express it in both magnitude and phase. Unlike resistance you just express it in only in magnitude. But in impedance, you express it in magnitude and phase. So for today's lesson, we're going to look at RC circuit in series. Now R stands for resistor, C is for capacitor. So we have a circuit here which is a supply, voltage supply, which is connected to a resistor and also to a current. Now they are in series. So the current that flows in the resistor and the capacitor, it is the same. Okay. Alright. So what we are going to do first is that we know in resistor, we know the resistance is R and the capacitance is C. So we know that the voltage here from here to here is VR. Okay. From here to here is VR and then from here to here is VC. Okay, VC. Okay, now we know that in this resistor, the voltage VR is equals to IR. Okay, and the voltage VC is equals to IXC, where XC is the reactance of the capacitance. Okay, so in order to find impedance, we cannot take VR plus VC. We cannot do that. We cannot solve impedance by algebraic sum. The only way to find the impedance is by drawing a phasor diagram. Okay, so I'm going to draw a phasor diagram. Okay, so here we see there's a current flow, so I draw a phasor for the current. Okay, I draw a phasor for the current which is in this direction I. Okay, assuming it's in the function of sine. Okay, so let's see, it's in the function of sine, so I is equals to I naught sine omega t. That's what I draw it in such a way. Okay, so when current flows in the resistor, okay, so what happens, we know from the concept. So I'm going to divide here resistor. We know in resistor current and voltage are in phase. Okay, from our studies, we know current and voltage are in phase. So I draw a phasor for voltage, which is VR, because they are in phase. Okay, and then in the inductor, in the capacitor, okay, in the capacitor, if you turn to page which I've teach you all, in the capacitor we know I leading V, correct or not? We know what? I is leading V. So if I draw in the phasor diagram the phasor for the voltage of BC, so it will be here. Okay, so then we are just going to look at this scope of the phasor diagram, which I'm going to draw here. This is VC, this is VR, and this is VC. Okay, and this is current. So from here, the total impedance will be in this direction, which is Z, which is equals to Z lah. Z, which is the voltage, is equals to IZ. Okay, now I'm just going to remove this confusion. Okay, V is equals to IZ, where V is the total voltage, which we can say is the applied voltage. And Z is the impedance. Z is what? Z is impedance. That means total opposition in the circuit. Okay? Alright. So how do we want to find? You see, when we want to find impedance, we need to have the phasor diagram, and we also have to have the magnitude. So how do we do that? We use theorem Pythagoras. Okay? So in this case, we can find Z. Z is equals to, or we put VZ is equals to VR plus VC, square, square, square. So I Z square equals to I R square plus I X C square. Cancel both, we get Z square equals to R square plus XC square. XC square. Okay. Then what do we do? Z is equals to square root of R square plus XC square. Z is equals to R square plus XC is 1 over omega C square. Okay, so this is the value of the impedance. This is the magnitude of the impedance, and this is where the impedance will be located in the phasor diagram. So now we want to know is the phase difference. We want to know the phase difference here. Okay, we want to know the phase difference between this V, which is the applied voltage, because the applied voltage is here, is the total voltage of these two. So we want to know the applied voltage and the current that flows in the circuit. We want to know the phasor diagram, which is, I'm going to label this. So we do like this. Tangent theta is the y-axis divided by the x-axis is VC divided by VR. Okay, alright. So VC is what? IXC divided by IR. So we get XC divided by R. So this is tangent theta. We can find the value of tangent theta. So from here we can deduce that this is the total opposition in the circuit and the current. We realize that number one, which is very important, we realize that current I leads the voltage. Current I leads the voltage. What voltage? Applied voltage. Okay. Alright. V. Applied voltage V. Okay. So that is RC circuits in series. Okay. Let's look at our textbook. Figure 18.10a shows a resistor and a capacitor. Connected in series. Series means the same current flows in both the resistor and the capacitor. So we have same current flows. I. The voltage across the resistor, this is the voltage across the resistor, VR is equals to IR. And in phase with the current. Okay, from what we understand, the voltage is in phase with the current. Okay, so you see the direction, they are in phase. The voltage across the capacitor, which is VC, is IXC. Okay, we know lags behind the current by 90 degree or pi over 2 radian. So if this is current, the VC will be in this direction. Okay. Yeah, so the phasor diagram, when you draw, this is the phasor diagram, okay, showing the phase difference between VR, VC and applied voltage. That means the total voltage. Okay, so the total voltage V is equals to I times Z is the total opposition in the circuit. So this will be the V, and this will be the V, which is V equals to IZ. Okay, so if I just separate with all those opposition in the circuit, here R, here XC, here is Z. So now what shall we do? We find the impedance. So it's a theorem Pythagoras. We get the formula for the impedance, and how to find the phase difference. Phi is the y-axis divided by the x-axis. You get the phase difference. Now from that we can know that the current I leads the voltage V. Okay, alright, thank you. RL circuits in series. R means resistor, L means inductor. So I have a circuit here, which is the voltage supply is V. Then it's connected to a resistor and an inductor. The resistor, voltage resistor is VR equals to IR, and here VL is equals to IXL. And then the same current flows in the resistor and also in the inductor. Okay, so what we do, the first thing is we draw a phasor diagram. Okay, I'm going to draw a phasor diagram. Okay, phasor diagram. Okay, so the current will be in this direction, which we assume sine. Okay, so this will be the current. Okay, and then we know in resistor, the concept says I and V are in phase. I and V are in phase. So when the current flows inside the resistor, they are in phase. So therefore this will be VR. Okay, then the current will flow into the inductor. We know the concept says in the inductor, what does it say? the voltage leads the current. Okay, in the inductor, V leads the current by pi over 2 radian. Okay, by pi over 2 radian. So if I want to draw the VL, so the VL will be here. Oh, not okay, VL. Okay, so now let's just focus in this part of the phasor diagram, which is here is VL, here is VR, and here is I. Okay, let me draw all the direction. VR, okay, and then we have BL. Okay, so we have this one is I. Okay, alright, so from here what can we say, class? We want to find the total opposition, so impedance will be here in this direction. Impedance will be in this direction, total opposition, where B equals to IZ. V is the voltage supply, Z is the total opposition. Okay, alright, so there must be a phase difference between the V and the I, which is the, we just put here. So how do we want to find? This is the phasor diagram. We know the direction already. Now we want to find is the magnitude. Okay, so how do we do that? V is equals to V square equals to VR square plus VL square. V is IZ square IR square plus with IXL square. Okay, alright, so we cancel, we get Z square equals to R square plus XL square. Okay, so Z is equals to square root R square plus XL, we know is omega L, so omega L square. So this is the formula. Okay, this is the formula. So now we want to find is theta, the phase difference between the V and the I. So tangent theta. Okay, alright. Actually, this one is phi. I not put theta, but the angle I mean theta lah, but it's phi. It's referring to phase difference. Okay, so tangent of the phase difference will be what? The y-axis divided by the x-axis. So it will be, the y-axis is BL. BL is theorem Pythagoras, class. How you find the angle in the theorem Pythagoras? VL, BR, I, XL, I, R. So we get XL over R. Okay, so that's how we find the phase difference. Now when you find the phase difference, you will realize that from here we can make a conclusion that the voltage leads the current. Voltage leads the current. Okay, voltage leads the current with a phase difference of phi. Okay, alright, so I want to look at your textbook. Figure 16.12 shows a resistor, inductor connected in series. Series means current flows in both the resistor and inductor is the same. Then we have alternating voltage V. So now we know that the total opposition in the circuit is the impedance Z. Okay, the voltage across the resistor is VRIR and in phase with the current voltage. The voltage across the inductor voltage leads the current by 90 degrees or pi over 2 radian. So then what they do, first they draw the phasor diagram, then they find the relationship between R, XL and Z, which is the magnitude, and they get the formula. Now then they find the phase differences, they get the formula also. But you must understand, this one is you must understand the concept, because the diagram can change. Okay, I want to make a correction here. It's a typing error here. It says the current leads the voltage. Okay, is actually what the voltage leads the current. So this one I think is a typing error. The voltage leads the current. Okay, all right. So just want to let you all know, what you should understand is there are this concept you have to know. It's a method you have to know how to do it. This circuit can change. Okay, it can change. They can put whatever they want to put and give it to you. Okay, so that's all. RL circuit. Let's look at RLC circuit in series. We have resistor, we have inductor, we have capacitor. Okay, so now we have they are connected. Resistor, capacitor, inductor are connected in series with the AC supply. That means the current that flows in them are in the same current. Okay, they are in series. Okay, so here we know this is VR equals to IR, VC equals to IXC, and VL equals to IXL. Okay, XC is capacitive reactance, XL is capacitive, inductive reactance. Okay, XL, inductive reactance. Okay, so if I draw the phasor diagram, the current is in this direction. The phasor, the current is in this direction. And then we know, okay, now I'm going to write down here, resistor, I and V are in phase. So I'm going to draw here is the resistor, which is VR. And then we are going to look at the capacitor. In capacitor, what do we know? With capacitor, VC lags behind the current. V lags behind the current. Okay, by pi over 2 radian, correct? So if I want to draw, it will look somewhere like this. This will be VC by pi over 2 radian. And then in inductor, the concept says in the inductor, we know that the V leads the current by pi over 2 radian. Okay, so if I draw it here, it will be in this direction. Okay, so what do we do first is we find the total voltage in the y-axis. So total voltage in the y-axis, we want to find the impedance. The impedance is somewhere around this area here. So we want to find the impedance. What do we do is we take VL minus VC. We draw another phasor diagram. Sorry. So VL minus VC. So I'm going to draw here with another color pen. VL minus VC. VL minus VC. And then this one is I. Okay, so impedance will be here. This will be the impedance, which is Z. Okay. Alright, so this also we can put here. Okay, alright, so we will get something like this. Also, even if you don't want to put it in this way, we can also put here VR. Okay, I forgot to put VR there. So VL minus VC. So total impedance I will write down total impedance is the total voltage V square, voltage that is supplied to the circuit, the total voltage that is supplied to the circuit. V square is equals to VL. VL is let me do VL minus VC square plus with VR square. So V is IZ square. Okay, VL is IXL minus IXC square. Just used to putting it like that. Okay, plus IR square. Okay, when you cancel, you get Z square equals to XL minus XC square plus R square. So Z is equals to square root XL minus XC square plus R square. Then we substitute inside, we can get something like this. XL is omega L minus 1 over omega C square plus R square Z. Okay, then we want to find tangent theta. We can go ahead and find the angle, which is the phase difference. Okay, we can do that, which I've already taught you all. Okay, so this is how. So they want us to use the formula. So if you see under your learning outcome in your textbook, they want us to use the formula. Okay, so you have to learn how to use the formula. Okay, then you see here they have this variation all drawn in the graph. So you realize here this is the minimum impedance. The impedance Z is minimum when the frequency F0 is 1 over 2 pi F0 C. Now that will happen when XL is equals to XC. This happens when XL is equals to XC. So XL is what? Omega L equals to XC is 1 over omega C. So omega is 2 pi FL equals to 1 over 2 pi FC. So we're going to put a 0 not here because it shows it's a minimum. So from here we get F0 equals to 1 over 2 pi square root LC. Okay, alright. So what is this? This is called as the resonant frequency. Okay, resonant frequency, we will study more on it in the next chapter, in the next semester. Okay, that's all class.